Okay, with 5.3, you're missing the first page, so we need to put that in here. So 5.3, page 1, what we're doing is we are solving. We're going to be solving these in general, and we're going to be solving them as exacts, but we're going to be finding the values. So here we start with example 1, 2 sine x minus 1 is 0. So we're trying to solve, and we're going to get to our x. So that means I'm going to move over the 1 by adding it. I'm going to divide by the 2, so I get 1/2. So I'm looking for what angle gives me the value of 1/2. Well, I'm positive, so therefore I'm quadrant 1 or quadrant 2, and 1/2 references 30 degrees. So if I'm asked for a specific exact answer, I am pi over 6 and 5 pi over 6. If you are not given restrictions, then you have to account for every single 30 degree that is in quadrant 1 and in quadrant 2. So if you're asked for in general, that would be pi over 6 plus 2 pi n, and 5 pi over 6 plus 2 pi n. Because the only way you can get back to this 30 degrees is if you go all the way around. The only way I can get to this 5 pi over 6 is if I go all the way around. All right? So you have to be careful of restrictions and be careful of the question. Is it asking you for exact answers? So there's only 2 of them, and they would say the restrictions are from 0 to 2 pi. Or is there no restrictions, like it goes on forever? Okay, let's look at the next one. Sine of x plus root 2 equals negative sine of x, and you have the restriction of 0 to 2 pi. Your answers have to be in that interval. So I'm going to solve for this. I'm going to move the sine x over. So 2 sine x and move over the negative 2. So sine x is negative root 2 over 2. Alright, well that's quadrant 3 or quadrant 4. That's where my y values are negative. Root 2 over 2 is 45 degrees, or pi over 4. So what is the 45 degree measurement in quadrant 3? It's 5 pi over 4. What is the measurement in quadrant 4? It's 7 pi over 4. And because I'm restricted to only one time around the circle, this is my only answer. I don't have any general solutions because I'm in a restricted set. Right? 3 tangent squared minus 1. So I'm going to get tangent squared is 1/3. So tangent is plus minus root 3 over 3. Remember, when you square root, you get 2 answers. Notice there are no restrictions, so I'm not looking for just one specific answer. I'm in all quadrants because I'm positive and I'm negative. And root 3 over 3 references 30 degrees. So how do I get to every 30 degrees? I'm pi over 6 plus pi n. That gives me this one and that one. So I need my other ones, and that's it. That's it. There you go. That will give me all of my quadrants here. Still need the negative ones, so I'm going to go over to here with this 30 degrees, which will put me over here at 5 pi over 6 plus all pi over n. So that will give me my other quadrants as well, my negative quadrants. So I have pi over 6, and it's 180, and then I have 5 pi over 6, and it's 180. So it takes care of all of my quadrants 30-degree measurements. All right, on page 2, if you have 2 or more trig functions, you want to collect all the terms on one side. And try to separate functions by factoring or using identities. So everything we did in the last section, we want to be able to apply. We want to be able to factor them. We want to be able to substitute. We want to be able to get common denominators. We want to be able to do all those things. In this case, I'm going to move over the 2 cotangent. So I get cotangent cosine squared minus 2 cotangent. Therefore, it equals 0. I can now factor out a cotangent. Then I get cosine squared minus 2. And it equals 0. Just like when I factor and I solve, I can do the same thing here with my trig identities. Each piece is going to be 0. Cotangent is 0, and cosine squared minus 2 is 0. Where is cotangent 0 at? At pi over 2. Here I'm going to keep solving. Cosine squared equals 2, so cosine is plus or minus root 2. Well, in this case, root 2 is greater than 1, so it's not possible. It's not in the domain. So that one gets rejected. Pi over 2, I have no restrictions. So the way I'm going to get to pi over 2 is if I keep adding 180 degrees. Here's pi over 2. If I keep adding 180, that'll give me this one, then this one, then this one, and just it'll keep going continuously. Because I don't have any restrictions, I need to do the general format for an answer. Alright, here's our quadratic. We're going to factor 2 sine plus 1 sine minus 1 equals 0. Therefore, each piece equals 0. So sine equals negative 1/2 and sine equals 1. Well, negative 1/2 is quadrant 3 and quadrant 4, and it references 30 degrees. Therefore, it is 7 pi over 6 and 11 pi over 6. But because it doesn't have any restrictions, I have to have all of them. So 2 pi n, 2 pi n. Because that's the only way I'm going to get back to 30 degrees in quadrant 3, 30 degrees in quadrant 4. The only way I get to those is if I go all the way around. Sine is 1 is at 90 degrees, so that's pi over 2. And the only way I can get to 90 degrees is if I go all the way around. Those are all of my solutions. Be careful of a general format and a specific format, because you're definitely going to have an interchange of those. You need to make sure you're paying attention to directions. Rewrite with a single trig function here, and then we're going to solve it. So first thing is we need to recognize sine squared and cosine are not the same. We want to replace the one that's a square because that's the one we have an identity for. So sine squared is 1 minus cosine squared. Distribute. And then put them in proper order. So minus 2 cosine squared, 3 cosine minus 1. All of this equals 0. We never want our leading coefficient to be negative, so we're going to switch the signs. Now I can factor this. 2 cosine minus 1 and cosine minus 1. So 2 cosine minus 1 is 0, and cosine minus 1 is 0. Cosine is 1/2. Cosine is 1. Where is cosine half at? It's at quadrants 1 and quadrant 4 at 60 degrees, which is pi over 3. And the only way to get back to it is with 2 pi n. Quadrant 4 is 5 pi over 3. And the only way to get back to it is with 2 pi n, or all the way around. Cosine is 1 is at 0 and 2 pi. So that we can just do all general is 2 pi n. Because if I put a 0 in there, I get 0. 1 gives me 2 pi. 2 gives me 4 pi. And I'll always come back to it. So those are my 3 solutions for that problem. On page 3, when squaring and converting the quadratic type, you always need to check for extraneous solutions, meaning sometimes they don't work. Like on that first one, we rejected something. Same thing could happen here. We might have to reject something. I have a cosine and a sine. If I have only singles, that means I can't do any Pythagorean identity substitutions. So I need to make them a square so that I have that possibility. So I'm going to square both sides. So this will give me cosine squared plus 2 cosine plus 1 is sine squared. I'm in cosine on the left side, so I want to change my right hand side to that as well. And one of the identities allows me to change that to 1 minus cosine squared. I now can move everything over to one side. The 1 goes away. I can factor GCF. And now set each piece equal to 0. So cosine is 0 and cosine is negative 1. Well, cosine is 0 at pi over 2. Cosine and 3 pi over 2. Cosine is negative 1 at pi. All right. So these are my solutions, but because I squared, I need to check for this extraneous possibility. And the way that I check is I just plug it in. Cosine of pi over 2 plus 1 is equal to sine of pi over 2. Well, cosine pi over 2, that's the x value at 90 degrees, is 0. And sine at 90 degrees is 1, so 1 equals 1. Now I have cosine of 3 pi over 2 plus 1 and sine of 3 pi over 2. Well, cosine 3 pi over 2, x at 270 is 0, so 0 plus 1 is 1. The y value at 270 is negative 1, so that one gets rejected. And then check the last one. Cosine of pi plus 1 equals sine of pi. X value at 180 is 1, is negative 1, which is 0. And the y value at pi is 0. So it checks. You will be required to show a check. It will say there on the test, make sure you show your check. Make sure you check for extraneous. So if you just come down and you give me answers and you don't do this check, that's about, you know, not quite half, but it's a good chunk of points. So make sure you're always checking anytime you square something. So here we have, we're going to solve for cosine, but the difference now is that we have multiple angles. On everything that we have done so far, it's just 1x, 1x. Even in this tangent squared of my theta, it's still only 1 theta. Here, cotangent of theta, cosine of theta. It's always of 1x, 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 1x. It's always of 1. Now what's going to happen is that it's no longer 1. Okay. So we're going to still approach it and solve it the same way. I'm going to get 2 cosine 3t is 1, cosine 3t is 1/2. So this is where it changes when you have multiple angles. You have to say cosine is 1/2 at pi over 3, or 60 degrees, and we're using our radians here. So we have to set 3t, because that's all of our angles, equal to pi over 3. And 3t equal to 5 pi over 3. The reason is because of quadrant 1 and quadrant 4. So here's quadrant 1, pi over 3, and 5 pi over 3, quadrant 4. So t then is, and we have to account for all of our angles. So it's pi over 3 plus 2 pi n, and 5 pi over 3 plus 2 pi n, because we don't have any restrictions on this one. So now I have all of this divided by 3, because that's how I'm going to get t, is I'm going to divide by 3. So that becomes pi over 9 plus 2 pi over 3n, and 5 pi over 9 plus 2 pi over 3n. When you have multiple angles, it's not just a matter of set each piece equal to 0 and solve it. You have to set each solution equal and solve. Next one, 3 tangent x over 2 plus 3 is 0. So first of all, I'm going to try to get this as lone as possible. So I'm going to get 3 tangent x over 2 is negative 3. Tangent x over 2 is negative 1. Alright, so here we're going to look at tangent is negative 1 at 3 pi over 4. That's the only place that it is. So that's the only solution, plus 2 pi n, meaning I don't have 2 quadrants. I don't have to worry about it. There's only 1 quadrant there that I have to worry about. And I set that equal to the multiple angle of x/2. Multiply by 2. When I multiply by 2, I'm going to get 3 pi over 2 plus 4 pi n. Okay. Last one, using an inverse function. We have 1 plus tangent squared minus 2 tangent minus 4, because I'm replacing the square so that I have the same, and then I move the 4 over. Put it in proper order. Factor it. Alright, I don't know 3 off the top of my head, nor should anybody. So in order to find the angle that gives me tangent value of 3, I have to do inverse. Or arc tangent. Going to punch that. You can just leave it actually. We get arc tangent of 3. And the only way we're going to be able to get that is by doing n pi, because there's no restrictions. And remember, the period on the domain of an inverse of tangent is pi, so that's why it's pi and not 2 pi. The other one, tangent negative 1. Well, tangent is at 45 degrees in quadrant 4. So it's negative pi over 4 plus n pi. And the reason for that is because, again, remember, the domain of arc tangent is quadrant 1 and quadrant 4. So that's why I can only be there. That's why I'm not in another quadrant with this. I'm only in quadrant 4. There's my solutions. And that is 5.3.